Welcome to the video on steam locomotives in Harz, from mining pump to tourism. We will explore the history, technology, and legacy of these incredible machines. What is a steam locomotive? It is a traction vehicle powered by water and steam, created in a boiler fueled by coal. The steam energy is converted into mechanical movement of the driving wheels. Locomotives were used for passenger and freight transport, and on public, industrial, and narrow-gauge railways. It was the first widely used mechanical land transport. Mining pumps, the technology where it all began. The problem in the 17th and 18th centuries was that mines were flooded with groundwater, with no effective way to remove it from great depths. The solution was the steam pump, the first practical steam engine, invented by Thomas Newcomen in 1712. The steam drove a piston, which moved the pump. Mining and coal were the cradle of the steam era. James Watt's improvements included the centrifugal governor, a mechanical device that automatically regulated engine speed. This invention allowed for safe and stable operation of steam power by reacting to changes in revolutions without human intervention. The balls on the spindle would move outward as speed increased, controlling the steam valve. George Stephenson's rocket was a pioneer of the steam railway. Built in 1829, it was designed for the Rainhill Trials competition for the Liverpool-Manchester Railway. The goal was to find the best locomotive for regular operation. Key technical innovations of the rocket included a multi-tube boiler for a larger heating surface and the blast pipe for exhausting steam into the chimney, resulting in better draft and more efficient combustion. Direct drive to the driving wheels also reduced energy losses. These elements became standard in later locomotives. The rocket achieved impressive performance for the 1820s. It had a maximum speed of about 45 to 50 kilometers per hour, weighed about 4.3 tons, and ran on coal. Its revolutionary achievements established the potential of steam traction. The rocket's historical significance lies in its victory in the Rainhill Trials. It provided a construction model for steam railways and proved that rail transport was safe, efficient, and profitable. The rocket initiated the era of modern rail transport. Hard coal was formed millions of years ago from plant remains in bogs and primeval forests, transformed by pressure and heat in the earth. The process involves the transformation of peat to brown coal and then to hard coal. Coal became a key fuel for steam engines and industry. The evolution of mining technology, spanning the 18th and 19th centuries, transitioned from initial manual extraction using pickaxes and shovels in open cast and underground mines. This was followed by the introduction of mechanical hammers, steam pumps for draining mines, and the first mining railways for coal transport. This improved the accessibility and reduced the cost of the raw material. Coal processing involved sorting by quality and calorific value, drying, and sometimes coking. Coke was used as fuel for metallurgy and heavy industry. Steam locomotives and industrial machines required high-quality coal with a high calorific value for efficient operation. Comparing the calorific value of coal versus crude oil, brown coal provides about 12 to 20 megajoules per kilogram, hard coal 24 to 30, and crude oil 42 to 46. Despite its lower calorific value, coal was cheaper and more readily available in the 19th century. Major coal mining centers in the 19th century included Great Britain, Germany, the USA, and France and Belgium. These regions powered the development of the steam railway and factory industry. Coal was essential for steam locomotives due to its high calorific value, which produced powerful steam in the boiler. It was also easy to transport and store in stations and wagons, and readily available across Europe and America in the 19th century. Without coal, steam locomotives could not function effectively. Steam locomotives enabled the rapid transport of coal from mines to cities and factories. The first dedicated railway lines for coal transport were created, establishing effective connections between mines, foundries, and ports. Locomotives accelerated the pace of industry and increased the availability of raw materials. Steam locomotives were catalysts for 19th century economic transformation. They provided stable energy for factories and accelerated trade and urbanization. The combination of coal, steam, and rail-powered modern industry. The Harz region presented difficult terrain, characterized by steep slopes and narrow valleys. Sharp turns and limited space required special solutions for track construction and adapting locomotives to the mountainous landscape. Technical adaptations for Harz locomotives included narrow-gauge design, reinforced boilers and brakes, and special cogwheel systems for better traction on steep slopes. This ensured safety and stability when transporting cargo and passengers in the mountains. The Harzer Schmalspur is a network of narrow-gauge mountain railways in the Harz, with over 140 kilometers of track. Steam locomotives have been in use since the 19th century for both freight and tourist traffic, serving as a living museum of steam railway. Historical examples of Harz locomotives include the 9959-01 Brockenbahn, which runs to the highest peak, and the 9972456, an industrial narrow-gauge locomotive. Locomotives from the 1920s to 1930s transported coal and wood, showcasing the development of steam technology in challenging mountain terrain. The historical development of Harz railways spanned the 19th and 20th centuries, from the initial mining railways built in the mid-19th century to the construction of a continuous network. Later, the line evolved into a tourist attraction, with the system surviving the division of Germany. The importance of the Harz narrow-gauge railway for the region is significant, facilitating the transport of coal and wood for mining and industry. Today, it is a major tourist attraction, contributing to the local economy and preserving steam railway heritage. Technical difficulties encountered included overcoming steep terrain, the need for specialized narrow-gauge locomotives, and maintaining the infrastructure in challenging mountain conditions. Continuous innovation and adaptation were crucial for the system's success. The challenges in the 21st century involve the high costs of maintaining steam locomotives and tracks, the need for skilled maintenance staff, and competition from other transport options. Preserving this unique heritage requires ongoing effort and funding. The Harz narrow-gauge railway is an important part of German and world railway heritage. It serves as an example of overcoming engineering challenges in difficult terrain and shows the potential of steam technology. It inspires future generations to preserve technical monuments. Thank you for watching this video about the history and technology of steam locomotives in the Harz region. We hope this video has sparked your interest in the fascinating world of steam trains and their legacy.